Welcome back to the deep dive. If you've been tracking the AI space, well, you've probably felt that huge buzz around AI agent protocols this year.
Oh, absolutely. They're popping up everywhere.
They really are, and they're becoming incredibly important. So today, we want to give you sort of the shortcut, the inside track to understanding these key developments.
Yeah, let's break it down. What we're essentially talking about is a shared language, a way for different AI agents, maybe built by different teams or companies, to actually communicate effectively.
A common language.
Exactly. You can kind of think of it like HTTP, the language of the web.
Yeah.
But this is specifically designed for AI agents talking to each other or to tools. It's the glue.
Okay, so why now? Why the sudden need for this AI HTTP? What was wrong with how things worked before?
Well, the old ways were, frankly, a bit chaotic. They were very framework-specific, often ad hoc solutions, not standardized at all.
So, like you said before we started, private chat rooms where everyone's speaking a different language.
That's a great analogy, yeah. Made true collaboration really difficult, almost impossible sometimes.
Right.
So these new interoperability protocols, they're a complete game changer. They fundamentally change how these multi-agent systems can interact.
And it makes adding tools easier, too.
Significantly easier. Yeah. Simplifies tool integration for each agent, making the whole ecosystem way more efficient, more capable.
Okay, so that's what we're going to unpack for you today. We'll look at some of the big ones, the popular protocols. We'll explore how they work, their sort of specific workflows.
But crucially, what they're best suited for.
Exactly. Helping you figure out which tool, which protocol is right for which task in this increasingly complex landscape.
All right, let's dive in.
So we've established why we need them. Let's get into the how. How are they making a difference? Let's kick things off with MCP. That's the Model Context Protocol, right? Started at Anthropic.
That's the one. Yeah, MCP. It's an open standard protocol, and it's designed for that two-way chat between an LLM, the large language model, acting as the client, and external systems, like various tools which act as servers.
Okay, two-way chat, LLM and tools.
Yeah, think of it maybe like a universal USB-C port, but for data sources and tools that the LLM needs to connect to.
A USB-C port for data. I like that. So how does that connection work day to day? What's the flow when an LLM uses MCP?
It's actually pretty neat. The LLM gets a query, generates an answer, or figures out it needs help. Then it chooses the right external tool for the job.
The LLM chooses the tool.
Correct. And importantly, there's often an optional step for user approval, for that human-in-the-loop security check. Keeps things safe.
Right. That makes sense. So the bigger picture here, this isn't just about fetching data, is it? It feels more profound.
Oh, it absolutely is. MCP is where LLMs stop being just passive knowledge buckets. This protocol gives them the metaphorical eyes and hands to actually interact with the real world, or at least real-time external systems.
Eyes and hands?
Yeah. They become dynamic agents. They can do things with external info, not just, read it and summarize it. They can act.
Okay, so MCP gives an agent its eyes and hands for tools, but what if you have multiple agents, multiple LLMs that need to collaborate with each other? That seems like the next challenge.
Exactly. And that's where something like Google's A2A, the agent-to-agent protocol, comes into the picture.
The A2A, agent-to-agent. Makes sense.
Its role is quite distinct. It's also an open standard protocol, but its focus is defining how AI agents, even if they're from different vendors, different frameworks, can find each other, talk to each other, and work together.
So MCP is agent to tool, and A2A is agent to agent?
Precisely. They're complementary, not really competitors. A2A handles that direct agent interoperability.
You mentioned agents needing to find each other. How does that actually happen? Is there some kind of, directory?
Sort of. It uses something called an agent card. It's basically a public JSON file. Think of it like a digital business card for the agent. It tells other agents or clients, here's who I am, here's what I can do, and here's how you talk to me. Makes discovery possible.
This feels like a big step. Moving beyond single agents to, AI teams.
Yeah.
What does this unlock?
That's exactly it. True AI teams. A2A is really best suited for enabling a network of, say, enterprise modular AI agents. Agents that can work together to solve complex multi-step problems.
Real-world tasks.
Yes, through structured and, importantly, asynchronous communication between agents. Asynchronous meaning they don't have to wait for an immediate reply. They can work in parallel.
Right. So complex tasks that maybe one agent couldn't handle alone?
Exactly. Now you can have an ecosystem of specialized AIs collaborating, all because they share this common language for teamwork provided by A2A.
Okay, so building on that collaboration idea, What about really complex scenarios, especially in big companies, maybe with older software, legacy systems? Does A2A handle that, or is there something else?
That's where you might look at IBM's ACP, the Agent Communication Protocol. It was released under the Linux Foundation, so it has that open governance feel.
ACP. Okay, IBM and Linux Foundation. How does it differ from A2A?
Well, if A2A helps agents find each other and collaborate broadly, ACP is kind of geared towards the really heavy-duty enterprise-grade stuff. It's IBM's open, vendor-neutral protocol specifically for standardizing the comms between agents.
Standardizing the actual messages.
Yes, it defines a RESTful, HTTP-based wire format. Think of it like defining the exact structure of the data packets being sent back and forth, ensuring reliability. Very much like how web browsers and servers communicate reliably.
Sounds robust. What capabilities does that enable specifically?
It allows agents to reliably exchange messages, assign tasks to each other, and interact both synchronously in real time and asynchronously. Gives developers flexibility for those really intricate workflows.
So it's sweet spot. For our listeners thinking about deployment, where does ACP really shine?
ACP's best use case is enabling agents to tackle complex tasks together, especially when you need to integrate with legacy software. Or if you need to stream data between agents reliably, handle cancellations properly, or ensure persistence, making sure messages aren't lost. It's built for that serious enterprise orchestration.
Reliability and integration seem key there. Okay, one more, Agora from the University of Oxford. This one sounded different. It has a unique twist, right?
It really does. Agora's standout feature is quite unique. It's a scalable protocol where the LLM agents can actually negotiate the communication protocols themselves.
Negotiate the protocols.
Using what?
Using natural language and JSON. Essentially, it transforms a user's natural language request into a standardized protocol on the fly, tailored for the specific interaction needed.
Whoa. Okay, so the workflow is, I ask for something in plain English, the LLMs figure out how they need to talk to each other or to a service to get it done, and they kind of generate the communication rules for that specific task. That's the core idea. The user request gets parsed using the LLM's capabilities, and then the agents generate the specific protocol needed for that service or interaction. Yeah. It's like they're writing their own little communication manuals in real time.
How does that change things for the user, for you interacting with AI?
Its best use case is definitely that natural language to protocol generation. It means users, potentially non-technical users, could define complex agent interactions and workflows just by describing what they want in natural language.
So it could make setting up these sophisticated multi-agent systems much more accessible?
Potentially, yes.
Yeah.
Far more intuitive. A very interesting approach.
It really is quite a landscape, isn't it? MCP, A2A, ACP, Agora, each carving out its own niche.
Different tools for different jobs.
And it seems clear that as these multi-agent architectures become more and more central to AI products and services,
They absolutely are.
then the need for these protocols, this bridge, allowing them to communicate effectively, is just going to become even more critical. It's a fundamental piece of the puzzle.
Absolutely. Which leads to a final thought, maybe something for you, the listener, to chew on. Given this rise of diverse communication standards, what happens next?
Yeah.
What new kinds of collaborative intelligence might we see emerge when these AI agents can truly speak a common language, not just within one company's system, but across all domains, all applications?
Wow.
What does that level of seamless AI collaboration mean for your future interactions with technology?
Yeah.
How might it change things?
That is fascinating stuff to think about. The possibilities seem huge. Well, thank you for joining us on this deep dive into the world of AI agent protocols.
My pleasure.
Lots to consider there. We'll see you next time.